All right.
What are you doing for Thanksgiving? Yeah, well, now my kids are grown up and stuff.
Yeah, or they all coming.
Yeah, they're both really nice. And then my in-laws.
Are you listening?
Although I made my husband.
Oh,
My mother
really?
wants to bring a bunch of stuff too, so I want to make it stuff I like.
Julie's a very good.
Oh, that's nice. Julie's a good cook.
Oh, is she?
Julie's a really good
So are you guys ready?
Sure.
I don't want to take all your time, but I want to talk a little bit about security because we didn't do that section. So we'll get going here in a second. Did you guys have a good weekend? No. I was very busy, so I didn't get grading done.
It's all
I'm
right.
kind of counting on Thanksgiving weekend to get it done, but we'll see. So anyway, just a little bit about security. And I thought I'd start on the big picture and then work the way down. I'm going to tell you a little bit more than you need for your assignment. And I'll even show you how to set up security in SQL Server, okay? Which you don't have to do for your assignment. It's mostly about what you would do. Okay.
Stealing data
All right, so we got stealing data
and altering data.
and altering. And there's a couple of other things I think. So one of the things is that these can come from outside, of course, right? So they can be outside hackers.
For some reason, turning down or there's a problem with the energy.
The energy?
And
Oh, yeah. One of the things we're going to talk about, that's actually a good point. That's actually related to something called disaster recovery. And that's actually the one of the databases that could hurt you that I haven't got, that have nothing to do with maliciousness, you know, like a power outage, like a hurricane or a storm, something that takes your servers offline or kills the power to your database, or your computer just dying. You know, there are lots of things. Those come under disaster recovery. A couple of things about stealing data and altering data. As I said, it can become, the danger of this depends a little bit on what kind of database you've got, right? Whether other people really would be interested in the content. A lot of businesses have some core data there. If you're storing customer information, that's a high value target. If you're storing credit card information, that's a high value target. If you've got stuff that is proprietary, like stuff that you patented and, you know, information about formulas and stuff like that, that could also be high target. Part of securing it for outside has nothing to do with the database. It has to do with securing your network, right? So closing ports, guarding ports, sniffing, keeping logs of all the people that attack. Any of you guys got firewalls that log how many people try to get into your machines? Because you'd be surprised, even like my machine that doesn't have a name, it's just an IP address. If you log it, there's hundreds of attacks every day. Basically because they're just broadcasting their attacks, right? Any open port, anywhere. They're just trying to find an open port. So, I mean, to some extent, that's a big. Now, again, most firewalls will keep that from they won't get in. But and it's also possible that they did get in, like on my machine, what would they find? Not a whole lot. So, but there is a constant outside thing. So securing the network, firewalls, keeping the users, logging all of that. That's actually something you get more in the networking class because databases reside on servers generally. And the server is a machine or multiple machines somewhere in an IT infrastructure. And so the network things are done. The more dangerous, though, and this is actually far more typical of an attack, is it's somebody from the inside, somebody that has permissions. You could think Edward Snowden, somebody that has a disgruntled employee, somebody that you fired but didn't take out of the network. Those are far more common attacks than outside.
Just be pure accidental.
That's another danger. So I'm going to do outside malicious, but there's also just inside, permissions, just mistakes, entering bad data. Now, so there's different kinds of inside mistakes. When I talked about in SQL, when you can do an update and you can turn everybody's name to Smith, that's something you need to guard against because that could destroy your database. And that's just a mistake. The other is just entering bad data in general. The more bad data, the less trustworthy your data is, the less useful your database is. So just having people enter garbage by accident could be a problem. This typically happens when you have like customer forms and stuff where customers enter their own information. I swear I know that, say for instance Unity, which is a C# platform for creating games, they have at least 5 profiles for me because I keep forgetting my password. And so they don't know that, but there's a lot of garbage in their database for that. And a lot of places have that, they just enter stuff and it's bad. At Petco, they got my phone number wrong and I've been trying to change it for months. So, those kinds of things happen, just bad data entry. So those are the kinds of things just in the broad picture, that outside hackers, depending on what you are storing in your database, that becomes more or less of a fear. Inside malicious, it's just a disgruntled employee or somebody that's working with permissions that has reason to steal or do damage. And then entering bad data. Those are the main threats. Other than, and we'll talk about this recovery, things that could just go wrong. Hard disk dying, that's okay. Computers, in general, storms. One of the, just as a preview, one of the big pushes on disaster recovery came after the first attack on the World Trade Center. Does anybody remember that?
Oh, yeah.
Not the ones where they came down, but the ones, yeah.
93.
Yeah. So they had they lost. It blew up a lot of their computer stuff. They lost billions of dollars. That money just went because it was all digital and there was no backup for it. And they began to realize that you had to start, having more robust systems. You couldn't lose one system and lose that much money. What?
What's staff-based storage on it?
Staff-based?
No, what's staff words like billings of dollars? Trading?
Well, it's not. It's actual money. If you think about it, if you think about the economy, our economy is worth what? Several $1 trillion, of which a couple million is printed.
Yeah.
All the rest of that money is just digits and computers.
In Mexico, when there are elections and they're counting the votes, usually sometimes they say, "Oh, I'm sorry, this."
Right. Yeah.
What kind of those?
Well, so they could be just.
Buying the election.
Yeah, that could be it. There could be lots of reasons why the computer could be down. One of the things that happens, this is actually a database thing too. is that if you aren't prepared for a huge influx of people, if your systems can't handle what they call concurrency. So when you're voting, you might have databases at the same time. They may not be up to that. So they may shut down in the sense that they can only allow in, say they can only allow in 100,000 and 500,000 people are trying to get in. That means that 400,000 people will be turned away. So that's something you have to plan for with computer. How can they handle the scope of the business? That's also part of disaster recovery. Machines could just die if they're old, and or they could just say, we don't want to count these votes, I suppose. One of the reasons why you've ever gone to a computer, so there's a computer you can vote by, but it's local to the site. Do you know what I mean? It doesn't feed to a central. Each voting machine just stores the vote, and then that is transferred later.
Physically?
I think it might be mailed up, but they don't have like a central computerized voting system. Partially because they're afraid of hacking. Although you can hack an individual machine, but that should be less damaging than hacking an entire system. And a lot of states don't allow electronic voting much at all. Even when you electronically vote, there's a punched card that is stored also. Someday, though, they do talk about making internet voting. I just don't know how they'll ever secure that.
Get chipless on it.
Yeah.
Can't handle that at Florida.
Yeah, with all the hanging chads. Is that
Yeah.
All right. So that's sort of the big picture. I mean, the big picture could go on for a long time. If you ever want to get a really depressing view of security, talk to Ed. He teaches networking. He's convinced that the war is lost, that the bad guys have the computer networks. So I'm not quite that depressed about it. I don't think it's that bad, but you can talk to Ed. He's the network guy, so he knows what, trying to protect it. There's two big principles when you get to the actual database: authorization and authentication. And actually, authentication is what we would start with. What is authentication?
Making sure you are using.
Yeah, this is the biggie in terms of just making sure you are who you say you are.
Keys, passwords.
Keys, passwords, the normal route, and it's the least secure thing you can imagine is a password and a username, right? And it's not secure because of a couple of reasons. Anybody have a couple that you can
Write
add?
it down.
Yeah, I mean, I write down all my passwords because if I have dozens of them, and I actually don't trust the
key.
the password things, the ones that keep your passwords. Yeah,
Plain text, right? Most passwords.
most passwords are transferred in plain text. Even if they're encrypted, there can be problems. Target, remember when they got broke into, they encrypted their password, but you enter it in plain text. And there is a moment in RAM where it takes the plain text and then it encrypts it.
Cycle it and take a screenshot.
Yeah, right. So what they did is, well, and they stole it from RAM before it was encrypted. So it was stored encrypted, but they actually, what they hacked was not the database, it was the machine where you scan your card. So there's other authentication things out there. There's anybody know of a couple of others? I just don't want to say everything.
It's like a retina scan.
A retina scan, although those are, they haven't really perfected those yet. Microsoft Surface has a new hello thing. It's not actually fingerprint, it's a face.
A picture recognition.
Yeah, it recognizes your face, and it's supposedly better. One of the problems with facial recognition is that a photograph used to work as well as a your face.
Mm.
But Microsoft's new one is 3D. So a photograph won't work. They have a 3D camera, so they check the depth. I know my daughter has, when they made her take, to use that, you have to get the measurements of your face with your glasses and without your glasses and all sorts of different things.
What if it's twins? Like, were you able to distinguish twins?
What? What if you had twins? Probably a twin could get in. So if you have yeah, if you have an evil twin, probably you don't want to use face recognition.
It was my twin, I swear.
Also, if you have I think twins have the same fingerprints if they're identical too, don't they?
I actually think they don't.
Do they? I don't know.
I'm not sure.
Because they're genetically identical. Although
Right.
fingerprints, I think, form in utero from probably different conditions, so they probably are different.
Fingerprints aren't very unique anyway.
No, and fingerprints don't work very well. It's one of the, if you watch CSI, they always can figure out the fingerprints right away. Most fingerprints are unreadable, even in the police files. And when they come up with a match, it's always a fairly low percentage match. It's different than, say, genetics, it's always a percentage match too, but it's a higher percentage match, but it's harder to get. Yeah. But yeah, fingerprints are usually not very good, especially if they're removed from the crime scene, because then they're usually smeared all different. Yeah. There were a lot of people convicted on fingerprint evidence that were later released because of genetic evidence. Okay, so there's another major way to do authentication. Anybody know?
Voice.
Well, there's voice. There's all the biometric ones. There actually are lots of things. Another thing that I think Microsoft worked with was where you'd have 4 pictures and you draw a line between the pictures.
Key cards. Another one, you use your eye, scan your eye.
Right, you can scan the card. Key cards, or actually another thing that they do when they're doing, particularly businesses sometimes do this, is they'll encrypt the whole drive, and then they'll have the key on the thumb drive, which is still dangerous because somebody can get the thumb drive, and you can't read the computer unless you have the thumb drive in there.
So it wasn't so you just scan the eye from.
Right, I know, an optical scan. That's pretty rare. It might.
Well, on the
Plus, you could take somebody's eye, the whole eye.
Yeah, I
The
know
movies.
that's in the movies. They might be able to tell the difference between a living eye and a dead eye, though.
also I saw another,
Pressurized.
Reactivity, you know.
I
Right?
saw another a way to do it use the blood. I don't know if that's true.
Yeah, but I don't want to bleed on my computer every time I want to log in.
Yeah.
No, no, it's more for like for safety, like the,
Yeah,
it's like it's not freaking awesome.
I suppose it depends again on how important it is what you're keeping on the computer. One big one that's out there though is certification. Certification is a sort of a bizarre way to do it. You probably all gone to a website. I think the schools here occasionally says that certification out of date. Do you trust this site? What they do is they pay for a certificate. The business or whoever pays for a certificate saying, I am who I say I am. And the only proof of that is that, would they pay to lie? Which maybe they would, but you never know. I mean, there's no particular. So you read the certificate and you believe that that is who they are because they have the certificate.
Could that be
So how is it different from a password? I mean, you're going to enter the certificate number or something.
Right. Usually if you don't enter it, usually it's transferred machine to machine and it's usually encrypted.
Okay.
Yeah.
That's one for the our website they pay for it, so that they have like the green button on the website that's saying save it.
What they do, they have, although it doesn't, the fact that they say they're safe doesn't mean they are. HTTPS is a more secure protocol, so it doesn't transfer things in plain text generally. So like when you enter your account number, what it does, in order to get an HTTPS, one, it's a slightly different protocol than just HTTP, mostly because it doesn't allow you plain text gets and puts and things like that. And but it's still not 100% secure. It could be broken.
Like sometimes, I think with the Google, sometimes shows like, this is Google.
Right. Basically, they do, though, if it's an HTTPS instead of HTTP, they put their little lock on there saying that it's secure. And it's more secure than if it weren't, but it's still not 100% secure. Even if the website is secure, and this has nothing to do with the database, although it could, I mean, it's a way of capturing passwords and stuff. If you let somebody get a keylogger on your machine, which is a malware, they can record every keystroke you make. And so they can get all your passwords, you know, and everything.
I feel like it's just like, cut out the data.
What is that called?
Keylogger?
Keylogger?
Some employers, see, there are legal versions of this because some employers put keyloggers on their workers to make sure that they're not surfing the web or accessing porn, or to make sure that they're actually doing what they're supposed to be doing. I don't know that I'd want to work for an employer like that. Although sometimes like Microsoft will do this for some of their machines, but it's for usability testing. You know, and testing. So what they're testing is how do people actually use it, and so they capture the keystrokes and the passstrokes. So there are legitimate uses for keyloggers, but it's also a really common piece of malware.
That's what Windows 10 does.
Windows 10 actually still captures kind of like Google, actually. It's just that Microsoft was behind Google in terms of capture of data. So they say they don't capture passwords or anything like that, but they'd like to know where you go, what you do. And they say they depersonalize it, they detach it from you and your machine, but it's supposedly so that they can improve Windows.
The whole depersonalized thing never seems to work out. It doesn't seem to take research. It's very long to figure it out.
Well, the thing is, like, and again, this is off base, but it's interesting. The NSA, when they take your phone records, they don't listen to, although they do sometimes, but they're not supposed to. They don't listen to the actual content of the phone call. What they're looking for are patterns of mainly, like, and this is a problem if you like are from Syria. But if you were calling Syria or Iran or somewhere a lot, you know, then you would be on their suspicion list.
But wait, what if you called Hawaii and had your friend from there call Syria or something?
Yeah, but they look for patterns like that.
Yeah.
They look for patterns.
They can follow it all.
The thing is that even if there's no person attached to that, it's pretty easy to work back to what the person was. So there are some arguments, and I think that with some validity, that we should have gotten rid of the computer stuff a long time ago for that reason. Everything we do is recorded pretty much. So authorization is the second step. And this is where the assignment kind of comes in. And we'll do the assignment, then I'll show you a couple of other things. And I will try to give you some time. For sure, Wednesday's open lab. So if you're here Wednesday, it'll be, you know, open. Because I'm not going to do anything new on Wednesday if you have to go to somewhere. What is authorization? Authentication is who are you who you say you are. And it's a complex thing, figuring out if you are who you say you are. What about authorization? What's that about?
If you have the power.
Right.
Permission.
Permissions. If you are who you say you are, what permissions do you have? All right, so this is basically what permissions. Just have two S's, yeah.
I think so. 3 actually.
Yeah. I wasn't counting the last. Okay, so when we do permissions, couple of general rules. So the biggest general rule is you should give nobody more permissions than, let me break this so it's on screen. than they need to do their job. So the idea is that you should never give anybody, I suppose I should give nobody, give anybody, anyway, never should give anybody more permissions than they need to do their job. Everybody should have the minimum permissions that they need, which can cause frustrations among employees. You do need to make sure that they have the permissions they actually need to do their job, but you don't want to give them any extra permissions, right? Everybody should have the minimal amount of permissions. Just as a side of this, SQL Server in the 90s and early 2000s actually had a really bad reputation for security. And one reason is that they shipped it wide open. They shipped it with all the permissions to yes. And they assumed that the database administrator would shut things down. But that didn't happen. So database administrators often just left everything wide open. So they were mercilessly attacked. So what Microsoft decided around 2005 is that they would ship with everything turned off. And the database administrator would have to go in and turn on the features. So that's how it ships now. And so you have to go in and turn things on if you want them to happen. All right. When I'm thinking of authorization, there are several. I'm going to do this, and then I think we'll set up a couple of things. And I'm trying to decide where I want it on this page, although it doesn't matter a whole lot. So permissions kind of correspond to SQL commands in a database, right? So the basic permissions are select, which allows you to do what?
Look at data.
Yeah, look at stuff. Select will not, you can't hurt anything with select. You can just look at it. Now, it can hurt if you look at stuff that you're not supposed to see,
Write
right?
something down. or something.
Yeah. So select is a permission that just to see things. You can't change anything in the database, but there's still some things that certain users should be able to see. Not everybody should be able to see your social security number, but in human resources, they may need to see that. Not everyone needs to know your home address, right? So those are things that shouldn't be seen by everybody. So select permissions are important too, even though they can't hurt the database. Then there's insert, which allows you to add data to the database. And then there is update. Allows you to change existing data, right? There's delete. Allows you to remove data from the database. Now there's some other permissions that I'm not going to focus on here, but I'll tell you about them. There's also create. Anybody know what create does? We haven't talked about it much. I showed you. You can create a table, but you can also create other objects. You can create stored procedures. You can create functions. You can create triggers. I mean, anything that you can create, any database object can be created with create. Alter is the same as update except for objects. So you can alter a table, and you can change its structure. You can alter a stored procedure. You can alter an index. You can change things with alter. Generally, in a business environment, nobody but the database administrator should have these kinds of permissions. But that isn't always true. I mean, if you have somebody that's doing a lot of ad hoc query kinds of stuff, you might give them the permission to create temporary tables, and things like that. There's also drop. Drop is like delete, except it's where you drop objects. So you could drop a table, and that table no longer exists. It's not just removing the data, it removes the whole table. You could drop a stored procedure. You can actually drop the database, which then the database no longer exists. One of the things about a lot of these is that there's no actual built-in undo either. Yeah, it is scary. You have to. That's why you have to be really careful with permissions. Again, only a database administrator generally should have drop permissions. Although there are ways to scale it down. Like you can allow people to drop objects that they make and no other objects, right? So there are things that you could do. Alter drop. Create alter drop. Is there anything else I was going to mention? I think that's it. Those are pretty much all the permissions. All the permissions kind of reside around these. So when you get into the actual things that the assignment are about, and I'm going to open up I'm not in my virtual machine, am I? Do I want to go through the process of opening it? All right, I'm going to insert a table here. I will open it when we do the actual stuff, but I think I'm going to delay that for a moment. I'm going to create a table. And I'm going to list like all the tables in, I think I need to make this smaller. It's probably too small. But I'm going to list all the tables in, say, community assist. So I'm not in there yet, but I know there's a person table. And there's a person address. There's a person contact too. I'll add that. And there's a deep donation table. It's okay if I don't get them all, and then there's a request. It's not called a request. I named it something stupid like service grant. I'm a very bad person for naming things. I mean, when I name them, I realize. And then there's one actually called community service, which is just a lookup table of services. That's probably good enough. I think there's some on reviewing and stuff. And then I am going to actually insert a row above this. I'm going to do select row. Update. Doesn't matter the order. Insert and delete. Okay. So let's think about this is sort of a table. Let's think about what users we would have for this. Anybody think of what users generally, broad groups of users for this? Community Assist, remember, is like a nonprofit that gives small amounts of cash to people for immediate short-term needs. Who would be users? Oh, there's also, what? There's an, yeah, so clients would be a good user. There's also an employee table. So let's think of the users. So there would be clients. Those are the people asking for the money. Is this readable at all?
Yeah.
Pretty vague, I know. I was just trying to.
Donors?
Yeah, donors. So let's just do clients, donors. One other big group of users. Employees, yeah. Now you could get more subtle. I mean, there might be subgroups of employees, subgroups of things. Let's just think about users and what permissions that they would have. Would they need to be able to look at all the people in the database?
clients don't be able to.
Yeah, clients don't. So let's actually, I'm going to put, maybe instead of tables here, I'm just going to put clients so we know who this one is. So clients, I would say no for this. Update on person, no, for certainly not. And probably no for the insert. Actually, they might need that if they, when they apply.
They could add information. Don't let them both take anything up or change anything.
Yeah, and delete would probably be a no. So insert, I put an X on. Actually, I know what that other column could be for. Notes. So when you say insert, only their own info, which the basic permission actually is pretty general. So in order to limit them to their own information, you'd have to create a stored procedure or something, which is we haven't done. I might show it, depends on our time. Probably not today though. Person address. So they might be able to select their own, right? I'm just going to put their own. Update, again, their own. Insert, so yes, for themselves. So I'm actually negating my note field. Delete, I would say no. Person contact, the same. So they can do their own information. And basically the same there and no. So what you're going to need for these are stored procedures because of that. Donation, because they don't even need to see that. Right, that's just a no straight across. Service grant, they do need to be able to see their own. So I don't know that they need to see what everybody's asking for. In fact, that's probably a real problem. Update their own. Insert their own. Delete, no. Community service is just a list of services, so I would say yes and then no to everything else. So they can just see the services that are available. Should they be able to see employees? They probably don't need to.
No.
Oops, I said yes, but it should be no. Do you see the kind of the pattern here? It just basically you're kind of making a map. The first thing is just to figure out who the big groups of users are. And then what kind of permissions would they have on each table? It gives you just sort of a map to go on. Does that make sense? So I am going to open up the virtual machine and I'll show you how to do this real quickly. And then I'll talk a tiny bit about disaster recovery and then be done talking, I think. Questions on this though? I'm being a little bit more, I think in the book, if you look at it, I just put X's on the permissions and then the notes were with, that they could only do it for themselves or whatever. I don't care that much. Something kind of like this would be useful if you do it just in bullets or whatever, it's okay. I think a little table like this makes it clearer. And again, it helps you when you actually go to the database to set this up. And it's really good idea, although we're doing it at the tail end of things, it's a really good idea to do it at the very beginning. Okay, so let me open up the virtual. So we'll do SQL Express, power on this virtual machine. And I just want to show you a little bit about the security. You could go on, we could do, in the summer, when I do the admin thing, I spend almost a week on the security. Come on, you can do it. It's been a while since I launched this machine. Hopefully it's not dead. Come on, at least give me the little circle.
What was our example database that we just did that table for?
It was Community Assist. It's one I did for when I first was showing SQL.
Okay.
It's available on why is it taking so long? There it goes. Why did that take so long? That was strange. All right, so let me log in here and we will do it.
Oh, yeah.
You shouldn't be so impatient. When I first started doing computing, it was normal to wait for like 10 minutes for things.
Watch their RAMs going up as you turn on the computer.
Yeah. I don't want to log off. Okay, so I want to just get SQL Server. Different database products have slightly different versions of this, of security. Do you guys want to see a graph using the interface? Both.
SQL, because I can save it for later.
We could do both, I suppose. It just takes a little longer.
The way we built our old ones was right.
Yeah. I'll do both. I'll do that and then I'll do. It's just the graphical interface. Again, you don't have to write anything. It's pretty easy in SQL too.
But like I mean, for my SQL, they try to do it for the website stuff. I'm used to
A lot of the MySQL is the command line.
yes.
But you can get like PHP admin and things like that. Postgres too is basically the command line. Even SQL Server, if you're in a professional environment, will probably be administered mostly through the command line because it's fast, it's efficient. The trouble is you have to know exactly what you're doing. So we have Community Assist, we have the DB database in the test, but I'll do the Community Assist. I am going to, couple of things. Let's go to authentication and do that. Notice that there's two differences security. You see, I can tell, but this security folder is for the database, and this one is for the SQL Server in general. Logins are stored in the SQL security here. Create a new login graphically. I can go down here, look at logins. Notice there's server roles and credentials. I'm curious to see what I have. Okay, so I don't have any logins. Let's do a new login. And there's two types of logins here. There are Windows authentication, which is the default, or the SQL Server authentication. Does anybody know what the difference is? I wouldn't necessarily expect you to.
Well, Windows will use your credentials.
Right, Windows uses your Windows credentials, so it's a pass-through from the Windows. Typically, it's pass-through from Active Directory. So having, like, even if you're an administrator on your Windows machine, doesn't make you an administrator automatically in SQL Server, but your Windows login gets mapped to SQL Server with whatever permissions that Windows, if you're on Windows. If you're coming from the internet, or you have a mixed environment where you have Macs and Linux machines and stuff like that, then that won't work. SQL Server authentication, which is what I'm going to do because I don't want to have to go in and create new Windows users. And then we'd have to log out of one and log into the other. It's just more of a pain. SQL Server authentication, you give it a login name. And so I'm going to call it just client login. Yeah.
So since we all kind of like log into your machine, so you do this, but we have access to that.
Sure, you have access to that in the virtual machine. Right.
Our virtual machines are all under your login.
Yeah, it doesn't matter because I'm not doing a Windows authentication. I did SQL Server authentication. SQL Server authentication ignores the Windows login. I mean, you can use the Windows login too. Any individual can need those, or there can be a SQL Server authentication. The SQL Server authentication requires a password, which I'm going to just make pass. Now, notice in order to do that, and you should never do this in real life, I unchecked enforce password policy. Makes it so you don't have to. You don't have to have any characters. One of them has to be a non-numeric, alphanumeric. One of them has to be a number.
Capital.
Yeah, you have to have a capital letter and a lower level letter. Password is the way minimum requirements. When I uncheck all of those, it means I can put whatever I want for a password, which is really bad. But I don't want to have to remember what my password is. Asymmetrical asymmetrical keys are for encryption. I don't want to go into a long lecture of encryption, but you can encrypt the whole database if you want. It does have to decrypt it, right? Encryption. Both the person sending the message and the person receiving the message have the same key. That's symmetrical encryption. That's the easy way, except that you have to make sure that both people have the same key, which can be problematic. It means there's more danger of somebody else getting the key. Asymmetric key means that the encrypted is different than the key used to decrypt it, which is safer but more complicated. Anyway, all that. Things that we have to do that. Make a couple of changes on the server. I'm going to go to the properties of the server. So I right-click on the server and I'm going down to properties. and I'm going to security on the server. Notice it has Windows authentication mode. That means it's only going to accept Windows. It won't accept the SQL Server login I just gave. Click on SQL Server and Windows authentication mode. That means that it'll accept either the SQL Server authentication or Windows authentication mode. You can determine what you want to log. I'm just going to do OK. And I'm going to get a message. This won't take effect until SQL Server is restarted. So I'm going to say OK. Now, a couple of things. Closing the video and restart. I'm going to right-click on the server again. And notice it pause, restart. So I'm start. This, and it says, do you really want to do that? And it's going to ask me again, do you really want to do that? And then we'll go. A couple of things from the very beginning, because in a lot of environments, stopping and starting your server is a really big no-no. Because you'd be offline for that period of time. So you pop offline while you do that. Now the login will work. So if we log in now, we've got that login allows you to connect. You have no other permissions. Once you're there, you can't do anything. All right, so what we want to do is map this client login to a database. And so the security, when I do community assist, there is a security folder for the way there. And in this there are users. There's actually a faster way to do this, but I think this is a clearer explanation. I'm going to, and if you look at users, there might be some extra users in here. Notice there's a donors login. Thing is that donors login isn't attached to anything. That's left over from another quarter. That donors login, if it's not attached to a login to the server, it won't do you any good. So just extra. But I'm going to add a new user. All right, so one of the types, SQL user with log. And notice, I don't know why Microsoft does this, but there are all these little 3-dot menu things. I guess it was easier than saying what it does. It's just at the end of it. So I'm going to do,
Click on it.
well, actually, first I need to give the, so let's say client user. And you don't have to click on this to do it, but if you do, you can go to logins and you can browse and it will show you all the possible logins. Yeah.
I'm sorry, it's go to users.
Right.
New user.
Yes. And I gave it a name client user. And then I clicked on the 3 dots beside login name. And here what I did is I did browse, and it shows me all possible logins, including client login, which I put a check mark by. And I do OK. You could have just written client login. And then the default schema, I'm just going to say DBO, because I haven't differentiated schema. We'll talk about that at some point. It creates a user. So the user, I haven't done OK yet. User, you give it a name. It maps to a login, right? You know, and if it doesn't map to a login, you can't get into the server, so you can't get into the database. And the default schema is database owner. It doesn't have to be database owner, but we don't have another schema active right now, so. And then when I do okay. Now, the thing is, I still don't have any permissions. I told you, Microsoft locks everything down. So the only permission I have is from the login, I can connect to the server. From this means I can connect to the database. I cannot read any tables. I cannot see anything. Do you want me to log in and prove that? Or? No? Okay. I mean, basically you have 0 permissions within the database other than the simple permission to connect. So then what you want to do is you want to assign permissions. And here's a general, I told you one general rule is never give anybody more permissions than they need to do their job. Another one is don't give individual permissions. If you can avoid it, what you want to do is to create roles. And what roles are is they're packages of permissions, basically. So you make a role, and then you attach the user to the role. That way, everybody that's a client has the same permissions. You can get in there. If somebody needs to be removed, you remove them from the role. You don't have to redo the permissions. You know, there are all sorts of, it just is a nicer way to administer things. Generally, you really want to avoid giving individuals different permissions from other individuals. It might be okay if you have a database where only 5 users or something, but if you have hundreds of users, maintaining individual permissions would be nightmarish. And it usually ends up as a disaster. So, under security, you might notice that we have roles. And there are database roles, and there's a lot of built-in ones. But I'm going to make a new one. I'll talk real quickly about the built-in ones. There's database access administrator. That just basically means that you can control permissions, right? That's the only thing you can do is assign set permissions. There's a backup operator. That means you can back up the database, but that's all you can do. You can back up and restore. There's a data reader. That's actually pretty broad in that it says you can read every table. Basically, it allows you just to read anything. And then there's data writer, and again, it's a bit broad because it just means you can insert and update in any table. Those are really good when you're testing, but they're not necessarily good real-life types of permissions.
Can a user have more than one role then?
Yes, the user can belong to multiple. It gets complicated, though, because Microsoft has the rule of least permission. So if the 2 roles contradict each other, and in one role it says you don't have the permission, and another role it says you do, the don't wins. The more restricted permission always wins over the less restricted. So you might want to do something like, I mean, your instinct or intuition might be put somebody in a role, but they need a few more permissions, and then give them an additional role, but it doesn't work that way. I guess you'd have to create a role for like super user or something, you know, as opposed to, because yeah, the more restricted permission always wins out. And again, so I'm going to create a new role, and again, just right click, new database role. I'll call it client role. The owner doesn't matter much. I would just browse into DBO again.
What did you put for the
Client role? And you could just type DBO in there. I'm not going to do anything in the owned schemas because I don't think the role should own any schemas. I am going to, are you guys with me so far? So a role is a collection of permissions. The schema is a collection of objects belong to things. So they could belong to a particular person. You could create a schema for that person. You could also create a schema with clients. And so where I would use a schema, though, isn't so much on the table, but I might make like the, if I did a store procedure, you can make it a schema that belongs to the client. But schema isn't permissions, it's objects. But you can attach a schema to a role so that you have the roles and the objects that go together. That's complicated. I don't know if I want to go there too much. In most databases, the schema belongs to whoever's logged in. So if you log in and create objects, those objects belong to you and your login. Microsoft decoupled, kind of like the word, decoupled schema from logins, which actually is ANSI correct. I mean, the standard's correct, but it's a little more complicated, but it's quite a bit more flexible. But we're kind of going to ignore it because it adds a lot of complication. So when I do securables,
Oh, to see the camera last time.
yeah, so this is still in database role. I'm doing securables. And I am going to search for securables. And I'm going to do all objects of types. So I'll do this again just in case you were behind. So I click on securables, search all objects of the types, and then it'll give me a list of the kinds of objects. So I'm just going to do tables. So it'll give me a list of all the tables. And then down below, let me maximize this. Oh, that didn't maximize it. All right, that didn't help a whole lot. So it lists all the tables, and then down below here it has the permissions. Notice it has alter. I'm not sure what the difference of control is. Delete, insert, the ability to reference it with a, like if you created a new object and created a key, referencing it as a foreign key. The ability to select, the ability to take, most of these are not and, but they're mostly the ANSI one. Mostly do like community services, just the list of services. So they should have a select option. So I can just click on select. I'm not going to go through the whole permission around here, but this is where your table could help you.
Well, we're doing this in our assignment.
You don't have to actually do it unless you just want to. I was just going to have you do the table part, not necessarily implement it. This is, as I said, part of the extra. Now, it only gives you the permissions for the table that's selected up here, right? So if I come down here to employee, they don't need to know anything. So if I go to grant review, they don't need it. Person, they need to have insert and update, though we will not want to create a way to focus that, so they can't update everybody. Again, that would probably be a stored procedure. Person address too, they would have. Oh, and they actually need to be able to select their own. Okay. Same with person address. So they probably need select, insert, and update, person contact. Oops, not that. Update, select, insert. Service grant, they need to be able to insert, select, and update. And again, you can control how that happens with additional code, but so that's all the permissions probably. When you've got all the permissions this way, you can do okay. Couple of things. You do not have any permissions that aren't explicitly granted. You don't have to ever deny something because you don't have the permission if you don't grant it. In the ANSI thing, definition of permissions in SQL, there's no such thing as deny. It's a Microsoft thing. Because if you don't grant it, it doesn't exist. With grant, I know you can't see the with, is a thing where if in a stored procedure or something, I could within the content of a stored procedure or something, give you permission on a table that you don't normally otherwise. So with grant means that you can have permission on it if somebody that has permission gives you the permission temporarily. So with a grant, and there's actually a SQL statement with grants, and then give them that permission. But mostly it's just granting. The permissions that you grant, you have. Everything else you don't. Now you can get even worse with this. So I'm on service grant, and you could do this. So notice it has column permissions, and you can click on this, and it gives you all of the permissions, all the columns in there, and you can determine which columns.
Mine's grayed out, so I'm just curious why
It
that.
depends on what table you're on.
Mine's service grant, because that's what you were on.
Should allow you to see the columns.
You can? It was over there, so they couldn't.
Yeah, I mean, it's not crucial now, but I'm not sure why it wouldn't let you see them.
Okay.
But you could determine which columns they can change and which columns they can't. So you can get pretty fine grained here if you want. I would suggest, rather than doing that, that you create views, which we'll talk about sometime. How are we doing for time? Not too bad. So I'm going to do OK. And I will, real quickly, I will log in just to show how that works. And then I will show you how to do it in SQL, which really will take 5 minutes. It's faster in SQL. So I'm just going to collapse these right now. I'm going to right click up here. Actually, let's right click up here. I'm going to connect to a database engine. It's still going to be SQL Express. Instead of Windows authentication, I'm going to use SQL Server authentication. I'm going to do client login. You always log in with, and password was pass. So I'm logged in now as with client login. I whiten that so you can sort of see that. Notice I have 2 different logins here. That can be risky. Test different logins. You can test different roles. You can make sure that things are working the way they want. And if you need to make a change, you don't have to log out of this and then log into this because you're already there, right? So you can have multiple logins going at the same time. So if I come down to here, so when I look at databases, I can see them all. That's partially because I said the schema was, but notice if I try to open the DVD database, it's not accessible. Test database is not accessible. Community Assist is accessible, and I can see the tables. I should be able to see some tables. Did I not give myself any? I thought I gave select on the tables, didn't I? Well, that's where we can go back up here. Databases, community access, security. Oh, you know what I didn't do? There's a major piece missing. Anybody think of what it might be? I'm going to go down to roles, and then go to client role, and I'm going to go to properties. Notice that there are no role members.
So that means you don't have any.
I don't have any permissions. So I have to add, I'm going to add client user to the client role.
Say that again?
I added the client user to the client role. The way I did it is I went add.
Oh, and down the bottom.
Yeah, and then I went to browse, and it gave me all the different kinds of logins that I've got. And then I did client user. I mean, gave me all the different kinds of users I've got. So I did client user. And then I did OK. So, and I have to do this in the upper one, right? The one that has full permissions. I'm going to do OK now. Down here, for this to work, I need to refresh. And now when I open Community Assist and open tables, I can see the tables. Because now I have the permissions that the role has. And I'm going to do a new query. And this query, I want to make sure that it's client login. So I'm going to do select star from community service, which is the one that we only have select permissions are. And that will, oh, what did I call it? Community service. I'm still in master.
Assist.
There we go. Okay, so I can see the services. But if I try to update that, set service maximum equal, let's say we really want a lot of food, equals 1,000. Where service key equals 1. Doesn't matter what I write here because it's not going to let me do it. Update permission was because I don't have update permissions on that table.
I have a question.
Yeah.
Could we also use AdMiner, or is the Microsoft version better?
It depends. I'm not sure I know AdMiner.
Oh, AdMiner is like not like that, but
For databases?
Yeah.
Any database? I don't know, because I don't know AdMiner. I mean, I would say that internally it's probably better to set up the structure in the
yeah,
database.
I've used AdMiner and Bill's classification.
Does it work with everything or only with SQL, MySQL?
I've only done MySQL, so I'm not sure.
Yeah,
I don't know about the other. I haven't tried it yet.
Yeah, I'd have to look into it. I honestly don't know. I don't know if it works on SQL Server.
It's on MySQL,
Is it only MySQL?
unfortunately.
I'm sorry, 2-4.
Let me, so, I mean, basically, if you look, you now have the permissions here. Another general rule is that even if you're administrator, you should never log in as administrator, which we are, because you can do damage by accident, right? You should only log in with the permissions that you need to do the job at hand. Okay, I'm going to show real quickly how to do this whole process in SQL. I'm going to come up to Community Assist up here on the top level where I have admin. And I'm going to do a new query there. So I did a new query up there. You can't do this in the other query window because it belongs. Query windows are logged into different users too. This is now up to Steve, which is fine. That's the one I want. If it says community, or if it says client login, then you won't have permissions to do any of this.
Oh, that's amazing.
Yes.
How did you switch from being?
So what I did is, notice, all right, here's my other login, which you could just log out if you want to. So I closed that. Up here at the top where it says SQL Express server and it says Steve as the person,
Mm-hmm.
that's the one that has permissions to
Oh,
do this. Yeah, and then I did a new query. So my other query was in the context of the other login and this kind of thing. Anyway, so this whole process in SQL, so I'm going to say, I'm going to start with use master, although it's smart enough it'll work even if you don't. Go is a Microsoft thing. It's basically there because it ignores semicolons. So I'm going to create login. Let's do donation user or employee user. Let's do employee. So let's do employee login. With password equal I'm going to break the line just because of so and password equals pass. Okay. So that's creating a login. And we could run that. And if I go to logins down here in the security, we now have, actually I need to refresh it. We now have employee login. Whoa, didn't want to do that. Okay, so that's that easy to create a login, a SQL Server login.
Is it in the Steve one or down below in the?
In the Steve one.
Okay, and it's under security users or roles?
Security for the server, so the outside security folder.
Oh, got you, okay.
And then I'm going to say use Community Assist, which it actually still is doing. And you could put a semicolon there if you want. As I said, it ignores them. Because other things don't. All right, so use Community Assist, and then I am going to say create user. A user. You could actually have it the same name. For login, employee login. So let me break the line. Actually, maybe if I just put that over to the side, pull this down just a hair. It's more cramped than usual. So that creates, and then where is my other thing? Did I get rid of it? Oh, employee or user for login, employee login. So that actually creates a user. Remember, this login is to the server. This is to the user. And then I will just add, we'll create a role. We'll call it employee role. It's actually that simple. Now I'm going to give the role certain permissions. I might actually give them more than that. Might actually give them like insert update. And basically you have to do this for every table. All the permissions you want them to have.
Where's the table?
What?
Well, it's okay, I'll just watch yours.
As I said, I'm not probably going to do all of them. And I'm going to let them add donations. Why does it not like?
Do you say to employee role?
Oh, yes, I do. Good eye. Do you see the pattern? I'm not going to do all the permissions. You'd have to think through what all the permissions would be. And I can run all those three together. And then I want to add employee user. So I'm going to use this built-in store procedure, SP add role member. And I want the role, employee role. There's other ways to do this, but this is, and then the member name, which is employee user. And that will add the person to the role. But I think actually that's a lot easier than the graphical way. And you could still add more stuff to the role if you wanted.
Well, you have employee role and employee user. It's camel case for employee user, but not employee role. Does that matter?
It doesn't matter. SQL is case insensitive. And that's true even on MySQL, even in Oracle. Okay, so just to show that this worked, I'll do a refresh on the security folder. This is the upper one, and this is inside the database. So when I look at users, there's an employee user. When I look at roles, database roles, there's an employee role. I'm going to right click on it and I had to refresh. They won't be there if you don't refresh. I'm going to look at the properties of the employee role. And if I look at securables, notice that it has the tables on community service. It has insert, select, and update. For donation, it just has select. And for person, it has insert, select, and update.
I lost you on, okay, employee role. So this is in the
So
upper security thing.
right. Community Assist database, down into security under roles,
Okay.
database roles, employee role, which should be there if you ran these.
Right.
And then I right click
Property.
properties. And then I looked at securables.
Oh, that's what I missed. Right.
It did the same thing that the graphics did,
Mhm.
right? It's the same thing that we did graphically, exactly. What?
It's much easier.
Yeah, I think the SQL
Just
is,
there's another command for somebody.
the SQL is fast. I mean, it's not, they're not hard commands.
Why, put the execution of the last line?
So the last line is a stored procedure. It's pre-built for you. Stored procedures are basically groups of SQL commands that are stored together as a single executable file. It's like writing stored procedures starts to feel a lot more like writing programming, like C# or something.
Like,
Well, so the arguments that this stored procedure require are the role name and then the user that you're adding to the role. No, the login is for the server and the user is for the database. And the role is at the database level. So if you've done this for MySQL with whatever tools, it's probably fairly similar. They may not have this stored procedure, but they have logins, users, and roles. Pretty much every database has at least that structure. Yeah.
So this was all just didn't, just different user.
Right, because you generally don't want to log in. And even if you're coming in through a website or something, you still don't want them to log in as administrators. Because if they do, they have powers. And there are ways to get around things called SQL injection attacks. And there are other kinds of attacks you can make on a database through an open text box in a web form. So what you want is to never have them connect as admin. You want them to connect with lesser privileges. So when they're logged in to registering to ask for a grant, they should be in a role that's specific to that when they go to connect to the database. That means that your website might have multiple database connections that change depending on who's using it. So if you log in as a donor, you have a different set of permissions than if you log in to register for a grant. And if you log in as an employee, you have different permissions you have to do.
Before we're done, can you just walk through quickly what the assignment is,
Sure.
just to map it back to what we just did?
I think most of what the assignment is, I'm going to kind of get out of full screen here. The assignment is more like this.
Oh,
Yeah, I'm not asking you to implement it in the database. I was showing you how, but I'm not asking you to do that.
cool, okay.
So it's mostly just think about your tables and your users, and then what permissions those users would have on those tables. That's all I was asking. I think I might have asked, I'll have to look, about disaster recovery too. Let me look real quick on, let's just go here. Does anybody have the assignment
I
up?
do.
Oh, so I actually listed the tables for you too, and then venues, artists, and songs. I didn't ask about disaster recovery. So let me talk a tiny bit about disaster recovery, and then I'll let you guys work, which I've taken up most of your time right now. What do you think, what are some of the solutions? I guess what are some of the disasters you could have, and then what are some of the ways you can work around that?
Power loss.
Power loss,
Hard drive melt.
how hard drive melts, yeah.
Fire.
Hurricane, flood. You know, lots of things can destroy your physical machine. What you want is so you don't lose data on that. There's lots of strategies for disaster recovery. If you're a mom and pop store, it may be as simple as copying your database, backing it up to a hard drive every night and taking the hard drive to a bank vault or something and swapping them out. If you're a big company, there are all sorts of things. Has anybody ever looked into that some?
Oh, we have like a business resolution plan. So we have to like log all this information every day. So that it's once it goes down.
Right. One of the things, if you're big enough and have enough money, is that oftentimes they'll duplicate everything in multiple sites. So, and one site might be here, and one site in California, and one site in Europe. You know, it could be all over the world. And they will duplicate the database contents and other information at all of those sites. That's an expensive solution, but a lot of companies do it. Just within, like for hard disk failure and things like that, most database servers have multiple disks. And actually, most database centers have multiple machines, all of which are copies. I mean, where you have multiple copies. 2 or 3 or to 5 to 100 machines all have the same database on it. And they're all, usually it's 2 or 3, keeping them in sync with each other. So if one machine dies, the other machine has an exact copy. You can do that through log shipping or mirroring, or there's all sorts of things that you can do that with. Again, it's expensive, but it protects you from the hard disk crash. Minimal, if you're just a small mom and pop, you should never have your log files on the same disk as your database. because you can recover a lot. You should have a backup, and you should have your log file on a different disk. So if the disk crashes with the database, you have the log file to help recreate the database. The log file keeps track of every transaction that has happened since the last backup. So it's good to have it on a different one. RAID systems, where you have your stuff copied across multiple disks, is a good idea. Big companies have what they call automatic failover. So if a machine dies, it instantly switches to a parallel machine, and that machine goes online. You know, so they always have at least 2 copies of every machine. Again, that's expensive. But it keeps you up. It used to be that you could take your database down at 3 in the morning and do some, you know, maintenance. But these days, with the global economy, it's 24/7 all the time. There aren't any down days and there aren't any slack hours. So it's harder to take things down. The failover system allows you to do that, though, because you could switch over to the second system, maintain one, and then switch back. So just disaster recovery is a really important topic, but probably bigger than what we're...
Are there cloud solutions that you?
Yes, one of the things you can do, and this is actually one of the appeals of the cloud, is that you could, one, you could put your entire business in the cloud. Most businesses don't like to do that because they just don't trust Microsoft or Google or Amazon, the big cloud servers. It's pretty good. Yeah, thanks. So you could put the entire business in the cloud, but then that means trusting your core business information to the cloud. It's cheaper to do that ultimately because you don't have to support your own machines. You don't have to hire as big an IT staff. All of the backup and failover and all of that is the responsibility of whoever you pay, you know, whatever cloud service you have. So the biggies are Amazon, Google, and Microsoft. There are others, right? Dropbox is a cloud service of sorts, and there are lots of other companies out there that are doing it too. What most companies have been doing is keeping their core business, but like Christmas is coming up. If you're a retail store, most of the year you might need, you know, X amount of database capacity, but for that 1 month, you need 3 times that much or 4 times that much. So you pay for the overload on the cloud. You use it for Christmas, and then when Christmas is over, you pull it all back down and do only your local stuff. So you don't have to buy the machines for just that 1 month of the year. Right? So the cloud is useful for that. You could back up your files, right? You could back them up to the cloud and then pull them down. That's becoming more and more of an option, I think, and it's partially just because the cloud is becoming more reliable. One of the bad things about the cloud, I store most of my files on OneDrive or Dropbox or Google Drive these days, rather than using thumb drive. But that's a real pain in the butt when your connectivity is down, because none of your files are available. So for the cloud to really work, you have to have constant connectivity, trustworthy connectivity, and you have to trust their security, that they'll keep your stuff safe and secure. Interestingly, Netflix goes down once in a while. It's almost always because Amazon servers went down on the East Coast. That's where Netflix is. It's weird to me because the #1 competitor for streaming right now with Netflix is Amazon Prime. So for Netflix to have their servers on Amazon seems strange to me. But
Give it the boot once in a while.
yeah. Cloud, you can do all your database work on the clouds too. I mean, you can set them all up there. Again, it's a matter of trust. It is cheaper on the cloud. It's not cheap necessarily, but it's cheaper. Because you don't have to maintain the machine. You don't have to maintain updates. They'll do the updates for you. You don't have to do backup and restore. They do that. They have failover built in. Of course, you know what the cloud is primarily. It's just warehouses of computers. Yeah, running virtual machines.
all the time.
There are some good videos. I'm done here, but there's some good videos of these warehouses. I mean, they don't even buy good computers. They buy really cheap junk because it's cheaper to pull a box out and put another one in than it is to maintain a box. And it's just stacks and stacks. Server farms go back. And the really expensive part is the air conditioning because every box puts off heat and they can get really, and heat, as you might know, ruins a computer. So that's why one of the more recent, I think it was Amazon, but it might have been Google, just built a warehouse in the permafrost in,
Oh, yeah, I just
Is
saw
that the
that.
Titan?
could be, yeah,
Titan?
so that they get the natural cooling. All right, so I'm done. You guys can work or go to lunch. Wednesday's open lab. If you need to leave early for Thanksgiving, you can, but you do also have the time here to work if you want.